Hello, I'm Annike and I'm working for the EEBUS initiative, and today I would like to introduce you to our reference test set app for all kind of devices related to the grid operator, as well as to test devices end-to-end functionalities. What you can see here is the Living Lab Cologne, a test space for practical testing of standardized communication related to interoperability. Here we can test all kind of devices and systems, real devices, real systems, but we are also able to simulate the grid operator's communication. Right next to me, this is Sebastian. He's our responsible test engineer and he will support me in today's demonstration. In our German pilot of the InterConnect project and its test site in Norderstedt, we test a solution for grid-compatible integration of electric mobility and heating. This solution considers standardized communication between every single relevant component and actor and all along the entire process chain. Therefore, we have set up a test system that consists out of the grid operator, an external market participant, the smart meter gateway infrastructure, a control unit, an energy management system, and a wall box which is connected to the electric vehicle. To integrate flexible loads such as EVs or heat pumps into the overall power grid, the grid operator must be able to limit the power consumption at the grid connection point of a building in times of impending grid overload scenarios. EEBUS has developed a communication interface for every single component and device that is involved in the entire process chain, which enables the transmission of a signal from the grid operator to the end device within a few seconds. We call this signal power limitation. Now Sebastian and I are going to demonstrate how this power limitation is sent from our grid operator simulation box to the wall box outside, considering the whole chain of components involved. And therefore I will go outside now and check with the EV in the wall box.
Okay, so I will now set a power limitation for the simulated grid connection point to 50% of the contractual power maximum. The local energy management system will then receive this signal and manage the power consumption of the wall box and the connected EV accordingly.
Right now this EV is charging with a charging power of almost 11 kilowatt. Let's see what happens once it receives the power limitation of the simulated grid operator.
So I now send an activated power limitation.
And here we have the drop down to 5.5 kilowatts, which means a power reduction of 50% or down to 50% and a successful power limitation. With its standardized use cases and interfaces, EEBUS provides the required solution to keep the grid stable and enable a large-scale integration of electric mobility and heating. With our test setup here in our Living Lab in Cologne, in combination with the full-scale testing in real buildings in Norderstedt, we set the path for future energy systems and a grid-friendly integration of flexible loads.